So for part 3 of part 1 of lab 3, we had to implement the right rotate of lab 1 onto FPGA board right here. I did so by using the 16 switches and 16 LEDs to input and display the A and B values, and I'm using 4 of the 5 buttons here to control what the lower bound and upper bound of the A and B values. So if we set a value for the lower bound and press this button, I have 3 switches flipped up, and then the LED is corresponding it. So if this button is not pressed, then it will display the lower bound of A. If it is pressed, then it will display the upper bound of A. Right now, upper bound of A has nothing, so if I press it, there should be no lights. Yep. And then if we go ahead and set, let's say, a shift value of 1 for B, this rightmost light should be moved to the upper bound of A. So set B, see, is gone. And then upper bound, this light lights up because it came from the lower bound. So if we do another test vector and move it by, well, this is the original value. If we do another test vector and say move it by 3, meaning I want these 2 lights to go up to the upper bound and only have this one light on the lower bound, I'll flip I'll flip the 2 switches corresponding to position 0 and 1, and then if I set the B, these 2 lights should be gone. Should move up to the upper bound, right? And then right there they are. So if we set, let's say, they just do some random values. Right. So lower bound, some random lower bound value, and let's set some upper bound value. Right. Here's the upper bound, lower bound, upper bound, and then let's shift it so that we want these 4 lights to go up to upper bound. In order to do that, we'll have to shift it by 6. So just flip the switches corresponding to 6, and then set the B value, and they should, these four lights, these rightmost 4 lights should go to upper bound. And then to confirm that, you see how the 4 lights moved? Here they are. So 2 lights separated by 2 off LEDs, and then 2 on LEDs. And then if we set the B value back down to 0, you should see the 4 lights goes back to the lower bound. Right, here they are. And then let's do 2 more test vectors. So here's the lower bound, here's the upper bound, and if we want to move it so that, let's set it to maximum shift, so 1111, which is shift 31 times. These, since there's only 16 switches on a there's only 16 switches and 16 LEDs, these 9 LED lights should move up to upper bound, and then the LED lights from LED values from the upper bound should move down to the lower bound. Let's see. Alright, so let's set the B value, and then here's the 3 values, and then yep. So original, here's the lower bound, upper bound, set B back down to 0. It should only be these 3, and then another 3, and then another 3. There you go. We can also test it by just moving it by 3 so that these 3 lights go up to upper bound. So if we set B to 3, see, those 3 lights are gone. These 3 the 3 that was here got moved over to the 3 empty spot, and then then the 3 that was here got moved to the 3 empty spot. And then upper bound should have I don't even remember how many, but these 3 are the ones that came from the lower bound. And then these 3 were here, the empty slot, and then these 3 were at the empty slot, and then there was another 1 all the way at the end. You can confirm it by setting B back down to 0. So, right, that one light that got turned on, and then yeah, that's basically how I did it for the right rotate. Thanks.